All right, so today we're going to learn how to solve a series parallel circuit. And what I mean by series parallel is if you look up here, we have a parallel circuit within a series circuit. Okay? We've looked at series circuits on their own before. We've looked at parallel circuits on their own before. But today we're looking at them together. And what makes these difficult is we're used to coming in here and saying that X amount of volts goes to each branch. We solve each branch separately, and then once we know our total resistance, we can figure out how many amps we're flowing over here and all that kind of stuff. But the problem with that is, since this bulb is right here, it is dropping a portion of the voltage from the source, which means we do not know how many volts are coming down each of these branches. And if we don't know that, we cannot solve for amperage on the branches, and therefore we cannot solve for total resistance in the parallel. So there's a lot of complications with this, and a lot of people will walk you through million-step processes, but we're going to walk through a fairly simple way to do this. What we're going to do first is we're going to pretend that this bulb does not even exist, or this load in our circuit. Okay? And if it didn't exist, we really would have 12 volts going to each branch, just like normal, because our battery is 12 volts. Okay, so that's what we're going to pretend. And if that was the case, we would do 12 divided by 4. We'd come up with 3 amps here. 12 divided by 4 again, right? And we would know that 3 amps goes through each of those bulbs. We would know that we have 6 amps total, and therefore our total resistance here would be 2 ohms. Okay, so since we know that this entire parallel circuit over here is 2 ohms of resistance, we're going to redraw our circuit like this, right? We're just going to pretend that this parallel doesn't exist for a second. We're going to bring this bulb back into play, and we're going to say it looks like that. Now, if we treat it like this for a second, we can now figure out that there's 3 ohms total in the circuit, and therefore there is 4 amps flowing. And we can say that 4 volts drop here and 8 volts drop here. Now this was the problem. This was the reason we couldn't solve this like we normally do, is because we didn't know how many volts, but now we do. So we're going to go back to our original equation the way it looked before, and now we do know that 4 volts drop on that bulb. And so 8 volts actually is what goes down these branches. And now we can just resolve again. 8 divided by 4, 2 amps. And 8 divided by 4 again, 2 amps. And so our total amperage is actually 4 amps. And our total resistance is 8 divided by 4 over here, which is still the 2 ohms like we talked about up here. But now we actually have real numbers. So we should know everything about the circuit, minus we haven't done our voltage drops. So 8 volts drops on this bulb, 4 volts drops there, 4 volts drops there. Okay, so we uncomplicated the situation by just kind of pretending that certain things didn't exist for a minute, applying our own fake numbers for a second or two, redrawing the circuit, and then going back with our real numbers once we know a little bit more. Okay, so hopefully that makes things a little bit clearer on how to solve series parallel circuits. And if you have any more questions, you can write them in the comments.